Hey, AP Chemisters, this is Mrs. Vandewally bringing you another edition of the Blank Wall series. Today we're going to start with section 12.5. We're talking about solution concentrations. That's all we're going to do. So have your notes and get a calculator. So we're going to be calculating today. The first ones are concentration equations. There's a lot more. If you actually check your book in section 12.5, you're going to see there's a lot of other ones. You're going to see molality and normality, but these are the three that the AP kind of really needs. They've taken away some of those other ones now. So the first one is molarity, and you should remember what molarity is. You really don't want me to sing it, do you? Because, you know, moles are on top of the mountain, and we have done molarity before. That was back like in chapter 3 or something. So molarity is moles per liter. So hopefully you remembered that. Here's moles per liter. Mass percent. Now if you think about mass percent, whenever you see a percent, always think part over whole. So in the case of mass percent, it is again part over whole, but it's the mass of what you're looking for divided by the total mass. Now make sure it is the total mass. It's not just the mass of the solvent. You want to add the mass of the solvent and the solute in this case. And because it is a percent, you're going to multiply it by 100%. The mole fraction is the Greek letter chi there. The mole fraction is very similar. It's going to be the moles of the solute over the total moles of the solution. So the moles of the solute and the moles of the solvent. So here's problem number 11. A solution is prepared by, should be massing, sorry, not missing, 1.00 grams of ethanol with 100 grams of water to give a final volume of 101. Calculate the following for the solution. The first thing is molarity. So to find molarity, if you look back up here again, molarity is moles of solute, in this case it's ethanol, over liters of solution. So what was the first thing? So again, we need to find the moles of the ethanol in this case. So as you probably figured, you're going to have to factor label to figure out moles of ethanol. So to find the moles of ethanol, I factor labeled the 1 gram divided by the molar mass, and I got 0.217 moles of ethanol. So now we're going to plug that back into our equation. So I substitute now the moles of the ethanol over the liters of solution. Notice that the volume here is 101 milliliters, so I divided by 1,000 to get 0.101 liters. And then if you do the math, you get this as a final answer. So your molarity is 0.215 molar solution. To find mass percent, you need to find the mass of the ethanol divided by the total mass. This is where people are going to make their mistakes. So here I put 1 gram of ethanol over the 100 grams. This is your 100 grams of water and your 1 gram of ethanol together. Multiply that by 100%. And so if you do your math, 1 divided by 101 times 100%, you're going to get 0.990%. All right, to find the mole fraction, let's kind of scroll back up again. A mole fraction, here it is the moles of, in this case, the solute, which is ethanol, divided by the total moles of solution. So if you recall, we already have the moles of your ethanol. There's your moles of ethanol, and then you're going to divide it by the moles of water. We haven't calculated that yet, so why don't you go ahead and calculate the moles of water. So I figured out the moles of water. We have 100 grams divided the molar mass is 5.55 moles. So now we need to just plug it into the equation. So the mole fraction chi is equal to the moles of the ethanol, which is 0.0217 moles, divided by, notice again, you have to add those two mole values together. So it's the moles of water and the moles of ethanol. So what do you get there? Well, I added those two together and I got 0.0217 moles divided by 5.571 moles. Now notice something. Do you notice that the moles are going to cancel out? And so your mole fraction, you don't have a unit with. You just leave it unitless. And so after you do that, you calculate and get 0.00390 is your mole fraction. Notice again, there's no units on mole fraction. So why don't you go ahead and pause this and see how you do with problem 12. And when you are done, I'll be right back. Okay, so we have another one. Problem number 12, a solution prepared from 45 grams of sodium hydroxide and 80 grams of water has a density of 1.39 grams per milliliter. Calculate the mass percent. So if you remember the mass percent means part over whole. So we take the mass of the solute, 45 grams of sodium hydroxide, divided by the total mass. That's your whole again. Remember that. 45 grams of sodium hydroxide plus 80 grams of water. So we have 45 grams divided by 125 grams. But don't forget, this is a mass percent. So you have to multiply it by 100% when you're done, and you get 36% by mass sodium hydroxide. Next, we got to find the molarity of the solution. I'm going to scroll up for a second. Hang on. All right, so now we need to find the molarity of the solution. If you remember, molarity is moles per liter. So we need the moles of sodium hydroxide. So if you factor label, you'll find you get 1.120 moles of sodium hydroxide. Now we got to find the volume of the solution. So we are given grams of the solution and we're given density of the solution. So we need to use that. So we have 125 grams of solution divided by this, how many grams in 1 milliliter. But of course, we need to convert milliliters to liters, so we get 0.899 liters. So now we need to actually put it all together and find the molarity of the solution. So now putting it all together, here is my formula. Molarity is moles per liter. We've already figured out what the how many moles of sodium hydroxide we have and how many liters of solution we have. And then I'll just divide the two out, and I got 12.5 molars. So last but not least, we need to find the mole fraction. Okay, so we need to find the mole fraction. If you remember what mole fraction is, it's the mole of your solute divided by your total moles of your solution. So to find out the moles of your solute, we've already done that. We've already found the moles of sodium hydroxide. That's 1.125. And next we need to find is the moles of water. So here are the moles of water. And to now solve for chi, I'm going to screw up a little bit here. So now chi, again, is the mole fraction. So it's equal to the moles of sodium hydroxide over the total moles of solution. Sorry about that. So you have the moles of the sodium hydroxide and the moles of your water that we just solved for. So that is equal to 1.125 over 5.56. I went to 3 sig figs in this step. So then my answer is 0.202. If you kept your number in your calculator is 5.555, you probably would have gotten 0.203, I think. So just make sure you have 3 sig figs, and that'd be great. Notice what else though? We have no units. They canceled out again. So why don't you go ahead and work on that third problem, or problem, I guess, what is it, 13? And honestly, try it on your own first, and then see how you do. So let's pause, and I'll be back. Okay, so hopefully you had time to work on problem 13 before you hear it from me. What volume in milliliters of a soft drink that is 10.5% sucrose? Sounds pretty yummy to me. No, it sounds really sweet to me. By mass contains 78.5 grams sucrose. They're also giving you the density. You're looking for volume. You know something about density, but we need to know what the density of the solution is, so we need to know what the whole mass of the solution is. All right, so it sounds like we need, because of this right here, the mass percent. So we know that the mass percent of sucrose over the total mass times 100% is equal to 10.5%. So let's plug in those numbers that we know of. So we know we have 78.5 grams of sucrose over the total mass. Now what I did is I divided both sides by 100, and the percent signs cancel out. So that is equal to 0.105, and if you do your math right, you should have gotten the total mass of solution is 748 grams. Now how does that help us? Well, we need to go back and now solve for volume. So now that we know the total mass is 748 grams, we can go ahead and solve for liters. So I factor labeled liters here. Come on. I think I did. It's not coming up. Hang on. All right, here we go. So we have 748 grams. I factor labeled using density, put the 1.04 grams in the bottom. That way the grams are going to cancel. So grams canceled out, but I now have milliliters on top. I don't want milliliters anymore. I want liters. So now I have the liters on top, and I do the math, and I get 0.719 liters. All right, so we'll probably be giving you homework over this tonight, or I'm sorry, tomorrow night. So hopefully that worked out, and just make sure you use your formulas. See you tomorrow. Bye.